Okay, I'm going to do this question here. I really like this as an exam question because it's scaffolded quite nicely. There's a little part here, do this, show this. So the first thing I'm going to do is I'm going to show PQ equals minus 4. Now, this is a slightly different question than before, that we don't know it goes to a particular point, but we do know it's at right angles at the origin. So that means this gradient times that gradient's got to equal minus 1, so I reckon I'm going to find that useful. So let's actually get an expression for that gradient and find the product of them. So part A, this point here is 2aq aq squared, and this point over here is 2ap ap squared. So rise over run. Now this distance here is the x, that's the y, so that's 2aq, that's aq squared. So this gradient here from 0 to there is aq squared on 2aq, and I want to multiply that by this gradient. Now don't worry about negative and all that, negative gradient, that will come into it a bit later. So the rise is ap squared over 2ap. Now we know that the product, because they're at right angles, has to equal minus 1. So let's go through and do a bit of cancelling. Now that q can go with one of those, that p can go with one of those, that a can go with that, that a can go with that, and we end up with pq on top and 4 on the bottom. Now what I'm going to do is I'm just going to multiply that 4 through to the other side, so we end up with pq equals minus 4. And that's what we have to do for probably 1 mark here. Now again, this style of question, that will be useful later when trying to combine our stuff that we know about x's and y's. So let's find the midpoint of PQ. Now this is very similar to everything we've done before. So, the x values is going to be 2ap plus 2aq on 2, and the y values is going to be ap squared plus aq squared on 2. These 2's can cancel. I'll get a factor of a out the front, divide through. I'll get x on a equals p plus q. And this one over here becomes a outside of p squared plus q squared on 2. Actually, I'll put the 2 up here so you can rub that out like I'm going to do. Now, what I need to do is I need to somehow combine these two together and eliminate the p's and q's, just get it in terms of x and y's and probably a's. I can see no, I can't see p plus q yet, so what I'm going to do is I'm going to rewrite this as p plus q all squared minus 2pq. So I've got a p plus q here, which is in terms of x and a, which is nice. And because I've already worked out what pq is up here, I can chuck it in there. So that means 2a equals a. That's an x on a all squared. PQ is minus 4 times minus 2 is a plus 8. So do a bit of expanding now. We get x squared on a squared times that a gives you an x squared on a plus an 8a. Multiply through everything by a. You get 2ay equals x squared plus 8a squared. Rearrange it. We get 2ay minus 8a squared. And I like doing this because you'll probably end up doing it at some stage anyway. So because it just says find the equation of Locus, you could probably stop anywhere from here's best, but anywhere in there's okay. But because I need to show that it's a parabola, I knew to get to there. So part C, show that it's a parabola. It's a parabola because it's of the form x minus h all squared equals 4a y minus k. And you can just write that, since this is of the form that, it's a parabola. So let's write down what its vertex and focal length is. Now vertex should be easy because it's in vertex form. So we've got a 0 attached to this x squared in this bracket here. So we've got a 0 there. And we change the sign. So because that k is a 4a, that's our vertex. Now the focal length can be a little trickier. Really, it's of the form 4a, and we've already got a 2a here. So a nice way to think about it is, this a is the focal length. Let's call that an a0. So if you say this 2a here has to equal 4a0, if you divide both sides by 4, you actually work out a0, which is really the focal length, which is going to be 2a over 4, which is a on 2. And that's the answer. So if you then had to find what the focus was and what the directrix was, you could add and subtract this to this point going up and down your axis to work it out. We don't have to in this case. That's all we need to do, stay with the vertex and the focal length are. That's a good question. I like it.